Thank you for being here. And I will talk about actually using a density as a mapping parameter for building material databases. So we know that we have to reduce environment impact of the construction industry. And so one of the tools that we use to do this is it's called life cycle assessment, and sometimes also use building performance analysis of different kinds. And the problem with this is that these usually use specific databases for the materials. So here I will guide you through a typical workflow that the designer has. And so first you have to develop an architectural model and with a context. And once you have done that, you probably will do some type of a daylight and energy simulation, and then you have to make a honeybee model or something like that, and to actually make this model accurate, you need to pick the specific material of each of the walls, windows, and roofs and floors. And so let's say that we have different types of walls and windows, then we actually have to look at this as a different material for example, different windows and such. And this can, of course, become very time-consuming, and that makes it so that people usually don't do it because they don't have time and it's not worth it, perhaps. And then when you have chosen all these materials, what you sometimes want to do also is a life cycle assessment. And here comes the problem with that this will have a different material database. So then you need to pick materials once again from scratch. And so this is the typical approach that we see. But now that you have to select a new material for each of the building components, for each of the analysis that you want to make. And this is what we propose, just choosing once and then trying to map it to different databases. And so this is a research question, like how do we actually do this? Using just a name or the ID of the material, and then using density as a mapping parameter. So we did two different case studies for this. The first one is a study with the climate database of the Swedish National Board of Housing, Building, Planning, and the second one is a more specific project in Switzerland. So this is the data that was collected, and for both of the case studies we have life cycle assessment and density, of course. And then as you can see, the first case study is much more focused on daylight energy, while the second is much more focused on strength of the material. And this is a typical workflow that we use for the first case study, and this is typical for life cycle building performance assessment. We use a daylight and energy analysis with ladybug and honeybee, and we use a plugin for grasshopper, which is called a Brimstone, which we use to make life cycle assessments. And this is actually how the mapping is actually done. So we pick a material, and then we actually manually search for like similar materials in different databases, and then we try to find relevant ones. And for the mapping, we just take the difference in percent of them. For the second case study, this was done on a school in Switzerland, and it was used with bio-based materials, and well, it was very hard to find the different materials for his, because it was there was a lot of non-conventional materials used. And so here we can see like how we are mapping it once again. So we are basically just dividing the densities of them, and we have tried to take like different types of materials for this, but we would like to make a bigger study with this. So this is for the second database, and yeah, we do the same thing here, and we see that, for example, the rammed earth material and straw bale insulation, these were actually used custom made for this study. And here we see some results, and we can see that generally it works pretty well for most of the materials. We have a deviation of which is lower than 15% for all the materials. But for the second case study, we see that for certain types of materials, like for the mineral wool, for example, we have a 64% deviation. So this is something that we should really think about when for certain types of materials it can be difficult to use a density. And yeah, for the last slide here, we have just that generally it's very important to make this whole process more time efficient, and also if we can just pick the material once, we can reduce the risk of picking the wrong material, and it would be very interesting to use, for example, natural language processing so that we don't have to do this process manually of finding different materials. So it could be done like a recommendation or automatic even. We have experienced with different types of parameters for mapping, but we found that density was performing best. And what would be perfect for us would, of course, be to make just one single database that could be used for many different types of simulations and analysis. But we found that it was very hard to find data on different types of materials. So let's say, for example, that we want to find data for like a daylight, for example, for an insulation material. That would not make sense, and so it's very hard to find, and so there become big gaps in the database. Thank you.